routinely move from one colony to the next, so they might be able to find some other place. Mass boobies, I'm not as confident on.
So I'm going to take the organizer's prerogative and ask one follow-up question to go back down the line about this adaptability element in climate change. And then it's going to be y'all's turn for the panel questions, so think of some good ones. You got to get us all the way to 12:30. So bottlenose dolphins in particular, I think, are a real challenge when you think of things like diversions, because they'd rather die than move, the coastal populations. Which, when you think about all the coastal restoration that's going to go on and how small those populations are, that's sort of really intimidating. But so is it when you think about beach armoring and then eliminating an entire nesting beach. How adaptable are these populations to these kinds of foreseeable challenges with coastal development and climate change? Kate.
All right, good question. So sea turtles, there are lots of different layers to this, and I'll try to do it quickly. On one hand, they've been around for 112 or so million years, and they've been through cycles of increased temperatures and decreased temperatures. They've gone through the Milankovitch cycles, and they've survived in some capacity. So turtles are, I think, very adaptable. However, the rate at which the change is happening now is much faster than the natural cycles, and what we do in addition to armoring and how we react to the changes to the beach profile may also kind of exaggerate and exacerbate the problem. So as far as, turtles have very strong site fidelity to both nesting sites and foraging sites. So if those foraging or nesting sites are impacted in some way, some level of stress would occur. They might have to expend more energy to find another suitable spot. And so it's an impact that could be translated into reproductive success, and among other things. Turtles are also animals that their sex is determined by temperature in the incubation environment. So we are seeing a trend towards more and more females coming from South Florida's nesting beaches. And some folks are saying, hey, the sky is falling, but within some nests, you may still have the ratios. It's just that more females may be killed because they're towards the top and they're under heat stress. So I think there's a lot more that we need to understand there. I think they are very resilient. I worry that we have a 20-kilometer stretch of beach, and we had last year Hurricane Matthew. This year we had another hurricane, and because the strength of the hurricanes typically hit during the late season, often the loggerheads, most of those nests have already hatched, but the green turtles start nesting a little bit later. And so the green turtles are the ones that have been impacted proportionally more than the loggerhead nests. And we're seeing this amazing recovery of the green turtles, and I think it should be sustained over time, because those turtles that came and nested this year in the 16,000 numbers of nests, in 2 more years they'll come back and they'll nest again. But if we continue to have these really large storms year after year after year after year after year, and the nesting beach is eroded and nests are washed out, then ultimately, maybe 20 years from now, turtle generation time, we will start seeing some of those impacts as well.
For Florida manatees, in regards to climate change and sea level rise and those sorts of things, I think it's kind of a mixed bag in regards to how the Florida manatee may respond. We know that, or we anticipate that there will be bouts of more extreme weather, and certainly for the cold intolerant manatee, if we see a lot of sort of hard cold fronts moving through, cold fronts of extended duration, it can certainly have an impact on manatees, especially if we're having challenges at the warm water sites. In regards to the warm water sites themselves, I guess some of the projections, assuming the power plants are still around when we see some significant effects of sea level rise, they may very well be underwater. If you're looking at the natural springs that manatees rely on, and when you have an increase in the height of water, quite frankly, it will have a tendency to reduce the length of the plume, and manatees won't have quite the same amount of area to winter in. I know we're also looking at saltwater intrusion into the aquifer. These springs not only serve as a warm water site for manatees, but they're also a source of drinking water. We would also expect to see changes in forage types. And we're already seeing that. For example, in Crystal River and Kings Bay, we're seeing a change from more freshwater vegetation to marine vegetation, which may or may not be an issue for manatees, just given the fact that they're a generalist herbivore and seem to eat just about anything. I don't know, we also, if you're looking at sea level rise, I don't know, as you see the water, moving up the shore, you expect to see a lot more turbidity. That turbidity in turn would likely shade out some of these grass beds and that sort of thing. We may see some initial losses in vegetation. Not sure how that might affect manatees either. We do know that manatees are fairly resilient. They've been through changes somewhat like this over the millennia. We know some of the glacial periods we had manatees, Caribbean basin, and they seem to have pulsed. You've seen manatees, focus in smaller areas, and as the glacial melt has occurred and you see sea level rise, the animals get into more areas and spread even farther. Seems that there may once have been concentrations of manatees up in the Carolinas during one of the interglacial periods, and so we could very well see manatees, move north, assuming the cold wasn't too severe and things of that nature. So I think probably see a mixed response on behalf of manatees.
So I'll try to touch on both right whales and dolphins. I think for right whales, if this year is any indication that climate change the progression of climate change could be pretty devastating to that population. We're not quite sure what's going on with right whales right now, but part of the thought for potentially the reason there were such a large die-off this year is that the animals are starting to go more north during the feeding seasons, and so they were spending more time up in Canada rather than in where they're typically seen, Cape Cod Bay. There was very small concentrations of animals there, and likely they're following their food sources, and which brings them into different anthropogenic threats. For example, in the area of Canada, which I'm drawing a blank on the bay they were, I think it was Bay of Fundy, where there was a lot of those deaths. There was a lot of snow crab trap pots in that area, which weren't heavily regulated because the animals typically aren't there. There wasn't any ship speed regulations because, again, the animals typically aren't there in such high concentrations and for such long periods of time. And so for such an endangered population with so few animals, without knowing exactly what they're going to do and not having those areas already well regulated, that's kind of a recipe for disaster, right? And this might be, unfortunately, a preview of what might be seen. The good news is that I think the Canadian government was pretty responsive. There was they had all the snow crabbers pulled. Once they realized what might be going on, all the trap pot fishery was shut down, and there was some emergency ship speed regulations. So I think in terms of for right whales, I can see climate change being very problematic for this particular species, given their critically endangered status. As for dolphins, for the resident and coastal populations, particularly the Bay Sound and estuaries, I think one of the things that the particular my field is concerned about mostly is the rise in disease as you have warmer water, more pathogens, and we've seen how devastating that can be to such a small group of resident animals, of only a population of about 200 to 300 animals. A couple years ago, we had a huge die-off on the Atlantic coast from what we think was the morbillivirus that just killed thousands, tens of thousands of animals. And so that could be problematic, as we know with climate change, warmer water can bring more disease, so that's going to be difficult. We're probably going to see more out of habitat animals, animals going farther up rivers to look for food sources, which, as Libby alluded to, often once they find a food source and they're happy, they don't move, and so we often, in some cases, we've had to go in and actually remove dolphins from rivers because they're covered in lesions. Their physiology can't handle the salt water, but they will stay there because the food's there. So that's going to be difficult, especially for these bay sound and estuarine animals. How will these animals adapt to their food sources moving, and the increased risk of pathogens moving through these populations?
Well, I think you guys summed up pretty well for manatees and right whales, as well as in general. I would add just a couple things that in the southwest part of Florida, particularly the red tide is a threat, and this may be exacerbated by climate change, certainly by increased nutrient load from increased human population in the area. So those in conjunction have led the experts to project that the red tide threat will increase in Florida in general, but particularly in the Southwest over the next 100 years. So that's one concern. Another point that kind of alluded to by several of you, that is that the difference between short-term shocks to the population and long-term threats. If the population is otherwise resilient, then it can survive. If it survives the short-term shock, doesn't go to quasi-extinction, then it can rebound from those when conditions improve again. But if it's facing other conditions that make it not as resilient, then the series of short-term shocks can add up to a long-term threat.
Now, Chris, I got the idea for the question from your answer, but I will give you the opportunity if there's anything that you wanted to say about adaptability and resiliency.
Yeah, I listening to all of my colleagues here, I was struck by something that we used to talk about a long time ago when I was in graduate school, which is the differences in mobility and vigility among the apex marine predators is quite different. So it might be kind of interesting to think about, I'll just pose it as questions, I guess. If climate change is going to manifest, well, I'm an optimist, so I'm going to back up and say all of these groups have been on planet Earth, the manatees, the cetaceans, the sea turtles and birds, been here a long time and have gone through all kinds of geological and climate bottlenecks before. So, and I don't know that the one we're entering right now is necessarily greater than what they've experienced in the past. Long term, I'm hopeful. But short term, it might be interesting to ask the question, which of these groups would be more vulnerable or more resilient to moving away and moving around problems that they could encounter through short-term shocks to the ecosystem from climate change. Like, I'm thinking of hurricanes or an increase in frequency of storm surges, differences in the erosion rates of nesting beaches, more frequent fluctuations from food supply for marine mammals. The three groups have quite different abilities to leave the area when they turn south and find other sources of either rest, breeding, or food. So it'd be interesting to ask that question. And for those people who model climate change scenarios, what are the short-term shocks? How are those going to change? And then how are these species going to adapt to that?
All right, so we have time for an audience question, possibly two, depending on how succinct question answer. Yes, sir.
So this is a question for Kate. It looks like the sargassum is really as important habitat in the life cycle as are beaches or any feeding meadow. Is anybody monitoring sargassum habitat?
I think that there is actually a group here that's doing a little bit of work, Dr. HU, not Dr. WHO, but, and there's a group up in the Carolinas that is also looking at some sargassum movement. I'm very interested in it. I'm not a sargassum biologist, and it's more, we have some crazy ideas of perhaps seeding drifters out with the sargassum to look at the movements and behavior. For those of you who aren't familiar with sargassum, it's a very transient sort of habitat. So if you have a young animal that has a nursery area, say in a forest, the trees are going to be there. The trees aren't going to just get up and uproot and walk away. And for sea turtles, they kind of encounter it, and it might be a lucky encounter. And I would argue that it probably is some sort of really strong benefit to turtles in North Atlantic. You don't find sargassum in other, necessarily in other ocean basins, or at least to the same level of biomass that we have here. And curiously, the turtle populations in the Atlantic, North Atlantic, are doing pretty well compared to other populations in other areas. Is that a contributing factor? I don't know, but it's curious, I think. And so, yes, I think that it is very important. There are different arguments, and some folks argue that, well, once a turtle has survived those 25 years and reached maturity, she has many years of reproductive output ahead of her. So protect the adult females, protect the nesting beaches, because that may be more important. I tend to argue that, yes, that's great, but you have to consider this turtle generation time, and if something else is going on, we may not know about it for a couple decades until we start seeing nest numbers drop. So it's very important to both understand and protect what's going on prior to that point of maturity in the nesting beaches.
Are there threats to sargassum?
Yes, I think that there have been ideas floated, especially with some of the restoration, to harvest sargassum, but you probably are a little bit more up to speed on that.
There was a harvest, I believe, off the Carolinas, which I think's now continued. There's a lot of interest in sargassum, and I know there are some research programs that I might be able to direct you towards that look at that. Sargassum is extremely important in the life histories of a couple of Gulf seabirds, mainly bridal tern and Audubon shearwater.
I think it's also very important for a lot of larval stage fishes too.
Yeah, the fate of sargassum under any scenario would be of keen interest for these marine predators.
Yeah, movements, behavior of it. I mean, you have little clumps that are found in streaks, and then the wind changes, and then you have a big mat, and then that big mat is broken apart when the wind changes again. So it's so incredibly transient. It's very, very, very cool. But it's also, I think, very difficult to model, perhaps. Hopefully somebody can do it.
There was a paper some years ago you may have seen that estimated or actually mapped sargassum in the Gulf of Mexico by associating a particular set of spectral properties that were available from the platform. I talked to someone this summer who said they haven't been able to replicate that.
Was this the Gower and King 2011,
Yeah.
which I had a slide of?
Yeah, but if you look at one of their images, the amount of sargassum in the Gulf of Mexico, at least at certain times, is staggering. It's defies comprehension in some ways. I mean, again, if the calibrations are correct.
I've heard that the visual, whatever the I guess the color-based remote sensed data has grossly underestimated sargassum, just because it's not picking up the color signature properly. So there's some folks, I think, in the Carolinas and probably here too, that are looking at better methods of seeing it and recognizing it, I guess.
Well, so in
Again.
order to get us down for our photo, I'm gonna end our session, but like our plenary speakers, we had, for our inaugural Marine Science Symposium, we've got this sort of unique artwork we commissioned for all of our speakers to say thank you for, in some cases, making quite a long trip to stay with us and give us some insight into your work and your expertise. So thank you. Thank you all for joining us. We'll do photo downstairs in the lobby, and then the lunch is going to be set up right out of here. And then the sessions start back up probably at 1:30. This room will be marine habitats, and then marine fish will be downstairs in the auditorium.